Hey guys, this is Mitch with Point CGI, and today we're going to talk about how to set up GD native inside of Godot. So we're going to go through the process of setting up our environment. We are going to download the Godot CPP project, and we are going to go ahead and set up our header file and our C++ file. And then we need to go ahead and set up a native module and set up our linking inside of Godot. And then we're going to go ahead and find a node below one of our other nodes, and we're going to go ahead and move that node around and things like that. So it'll give you kind of a basic fundamental of how this works inside of Godot. So that's what I have in store for you guys today. So let's go ahead and get started. Okay, so the first thing that we need to do is we need to make sure that we have some kind of C++ compiler. So we are going to need to download Visual Studio here. So we'll go ahead and pull this down. So click on download Visual Studio and go ahead and pull down the Community Edition. You can use the Community Edition as long as you don't make, if I remember correctly, I think it's over $1 million. And if you do, then you have to purchase the Professional Edition. But don't quote me on that. But right now we're just going to pull down the Community Edition and we will go from there. Okay, so now that we have our VS Community Edition pulled down, if we double click on it, you'll see that it's going to go ahead and extract it and allow us to install. Now I've already have Visual Studio installed, so this is just going to be real quick here for me, and I can kind of show you guys what you guys need to download. But I already have it installed, so it's not going to run through the proper setup procedure, but we can go from there. All right, so run through the Visual Studio setup, and once you get to this point here, what you need to do is you need to make sure you have desktop development with C++. And if you really want to be specific, if you go to individual components, there is a couple of things here that you have to make sure you have. So for instance, having the C++ redistributable update, the Clang compiler for Windows, Clang CL for version 142 build tools, CMake would be useful, and the modules for V142 build tools. You want to make sure you have at least that and MS build, and I believe that's what you have to have before you can go ahead and compile inside of Godot. Or inside of Visual Studio, right? But if you want to make it easy, just make sure you click on your desktop development and just pull that down. It makes things so much easier. Now, the next major thing that you're going to need is Python. Python is awesome, and we need to have scans to do, or scons, depending on how you say it, but scans to do our compiling for us. So make sure that you go to Downloads and download Python and install that as well. Once you have Python installed, if you look here and you type in Python, you'll see that I have Python 391. And, oops, I need to exit. And once you have Python installed, all you need to do is do pip install scans. And once you do that, it will go ahead and install scans onto your Python system. From here, you can access scans directly. So if I type in scans and I hit enter, you'll see that there's no S construct file found. So that means that we have scans installed. So now that we have all of our prerequisites installed, what we need to do is we need to set up our project. So what we're going to do is we are going to go ahead and open up Windows File Explorer and open up our file location that we want our project to exist in. So what I'm going to do is I'm going to right click and add in a new folder, and that folder is going to be called Godot C++ tutorial example. All right, and then we're going to go inside of that, and we're going to go ahead and do a git bash here because we're going to need git. So we'll go ahead and open that up since we need it already. And then what we're going to do is we are going to go out to the Godot engine CPP file here, this project here. And this project has all of the things that we need to create our plugin. So let's go ahead and click on our code and copy this little link here. So let's click on this little icon here, and that will tell us that it's copied. And then we will go ahead and open up our tutorial example project inside of Get here. And if you don't have Get, go ahead and pull that down. Just go into Google, type Get, download it, and grab it. And the link to their GitHub repo is in the description below. So what we're going to do is we're going to say get clone --recursive. And then we'll go ahead and paste that in. What that's going to do is that's going to clone that into our CPP folder here. So if I open up our Godot C++ example, you will see that we have Godot CPP. That is what we need for us to be able to compile our plugin. So what it's going to do is it's going to allow us to build our C++ bindings. So what we're going to do from here is we're going to cd into that directory. So cd Godot CPP, and you'll see that we have master here, which means we are inside of a Git repo. So that's how we know we've done this correctly so far. So now what we can do is we can go scans platform is equal to Windows. And what we're going to do is we are going to say bits is equal to 64 space generate underscore bindings. And my numlock was not on. There we go. Generate bindings is equal to yes and -J8. Now, you don't have to have -J, but -J will use up more system resources, so it will compile faster. Now, this step here is going to take a while, so go ahead and get yourself a cup of coffee or something like that and you know, take a break. Once it's done, we'll get right back to it. All right, so you can see that it's completed. So now what we need to do is we need to come into Godot CPP and go into bin. And you can see that we have a libgodot-cpp.windows debug 64 lib. So what this is it is a C++ binding. And what that means is it's a way to bridge the gap between two different languages. It's a library that we can use to interact with our plugins with the C++ engine that is Godot, if that makes sense. It's kind of complicated to explain it, but basically think of it kind of like a map that you have to talk to Godot with your C++ code. Now from here, we have to go ahead and make our project. So let's go out to our tutorial example area and let's go ahead and open up Godot. So in my case, I'm going to go ahead and open up Godot and I am going to go ahead and make a new project. We are going to browse out to my E drive and we're going to go to C++ tutorial example. We're going to select this folder and we are going to call our project CPP example and we're going to go ahead and create that folder here. And we will go ahead and create and edit. I'm going to go ahead and resize Godot for you. There we are. So now that we have our project open, let's go ahead and open up our C++ tutorial example project. Let's right click new folder and let's name it SRC. And what that's going to be is that's going to be where our source files are. So from here, I'm going to go ahead and open it up in my editor of choice, which in my case is Visual Studio Code. So we'll open that up. There we are. And I'm going to go ahead and resize this for you guys. Awesome. So now let's go ahead and right click our SRC file here, create a folder, create a new file, and let's call it
helloworld.h, and this is called a header file.
So what a header file is think of it kind of like an interface. It's an instruction set for your compiler, for the C++ compiler to be able to reference what functions go with what classes, right? Because if you look at a C++ file, it only has a function that says, hey, go do something, right? But it doesn't link back to the class or any additional variables or anything like that. That's what a header file is for. And it also allows you to link functions into different files and have them link back to the same class, which is super useful because it kind of reduces that whole copy paste aspect of coding. So it's really a decent way to go about organizing your code. So the first thing that we're going to need to do is we are going to need to go hashtag if ndef hello world. Whoops, I missed the O. Hello world. And I'm going to give it an underscore H. This is just common practice, but you don't have to do an underscore H, but I do it just for common practice. And what this does is it's saying, hey, if n defined, right? So if not defined, hello world H, then I'm going to go ahead and define it. So define hello world underscore H. And that'll give you a really good clean starting point. So that way you're not getting additional hello world classes inside of your C++ project. So it just says, hey, if this isn't defined, here's a definition of it. Now, something that you may not have that I glossed over is the C++ pack with Visual Studio Code. So if you come over to your extensions, you can see I have the C and C++ IntelliSense. So you can actually just come in here and type in C++, and that's the first one that comes up is this one. So make sure you install this or else you're not going to get auto completion. So that's something to keep in mind. I'm going to go back to my Explorer and click on Hello World, and we'll go ahead and continue. Now, the first thing that we need to do is we need to have our includes. If you know anything about C#, your includes are your using statements, right? So it's just adding in references to code that's outside of your project. So what I'm going to say is include Godot.hpp, and that is the entirety of the Godot engine. So you can use this to access objects and things like that inside the Godot engine. So now from here, we're going to type namespace Godot, and we are going to open and close our braces. And we're going to say class, and you can see here I have a code snippet. So I'm going to go ahead and use that. And what that's going to do is it's going to kind of template all this out for me. Now, you don't have to use this, and you can type private, public, and these little hello world constructors. You don't have to have these in here, but you can. If you don't, you can just go ahead and type these. So what are these? So you have your class. You have private, which is all of your private variables and functions. You have public, which is all of your public variables and functions. And then you have your constructor here. And then you have your destructor here. One of the big things that's will be new to you is the destructor. The destructor is when this object gets destroyed, what happens. So you could say, hey, before this object gets destroyed, I need to go and delete some data, or I need to go and run a small function to do some things, right? It gives you that flexibility that we were talking about in the C# versus C++ versus Godot script tutorial. So if you guys haven't seen that, go ahead and take a look at it. From here, what do we need to do? Well, you'll see that we have a squiggly line here that says, hey, hold on a minute, include error is broken, right? We have some errors detected. Please update your include path. Squiggles are disabled for this. And it's having some trouble with our include path, right? Well, the reason why is because if and def is an if statement. So we need to come down here and end that if statement. So we have to go hashtag end if. Because what that's going to do is that's going to link these two up saying this is one big code block here. Then we're going to go ahead and save. And you'll see that squiggle's still there. It's because we're missing our hello world.cpp. You can see that it's saying, hey, we're missing that hello world. So from here, let's go ahead and create that. So let's right click new file, hello world.cpp. And now if we go back to the header file, you'll see that it is fixed. So that's awesome. Now, if we go back and we stay at our header file, the first thing that we need to add to it that's Godot related is our macro called Godot class. So Godot underscore class, open parentheses, close parentheses, and we need to pass in a class for us to register with Godot. In this case, we're going to pass in hello world. And we need to pass in something for this Godot class to kind of register it under. In my case, I'm going to do a node2d. But if I type node2d, you'll see that I'm not getting any completion, right? And that's because while we included the Godot engine, we didn't include the small components inside of the Godot engine. So for instance, hashtag include node2d.hpp. So now I can type node2d. And you'll see that I also don't have a node2d here. And the reason why is because inside of Godot, the classes need to inherit from something. So we'll type colon public node2d. And what that's going to do is that's going to say, hey, we're inheriting from the public version of node2d. So that way we can inherit all of that code. And also under our Godot class, we need to tell it to also inherit from node2d. So we're basically telling Godot that this object inherits from node2d. So think of it kind of like this. This is telling C++ we're inheriting from node2d, and this is telling Godot that we're inheriting from node2d, if that makes sense, that these two are linked. Now, one last thing that we're going to need in our header file is a register method function. So I'm going to type static void underscore register methods. And what that's going to do is that is going to allow us to register our methods inside of Godot. So any methods that we have, we can register them inside of Godot. And now from here, we can go ahead and declare any methods that we want. So in my case, I'm going to declare void underscore init, and I'm going to declare void underscore process. And that is going to take a float, and that's going to take in a delta. Awesome. So what did we do here? Well, basically, we included our Godot nodes and our Godot engine. We put ourselves inside of the Godot namespace. We created our class and inherited it from public node 2D. And we registered our Godot class, our Hello World class, with our node2d inside of Godot, saying that these two are related. We also created our register methods method, and we have our constructor and our destructor, which are also down here. We created our initial function, which runs when Godot boots up, and we have our process function, which runs while Godot is running. Awesome. So now that we have all of that, and I know that that was a lot, but I promise it gets easier as time goes on. Now that we have that, let's move over to our CPP file, and let's say hashtag include quote hello world.h, and that's going to go ahead and include our hello world. Now you'll see a squiggly line under there. Don't worry about it. That's just C++ being dumb. It doesn't see that the hello world.h file is in the same folder. I'm not sure why that is, but I've had it compile just fine. Now from here, we're going to say using namespace Godot. And then from here, we need to go ahead and start setting up our Godot file. So if we come over here and we take a look at what we have our static register methods, we have our void init, and our void process. So let's come back over to C++ and create our register methods. So void hello world ; underscore register _ methods. and we'll open brace and close brace. And I am going to go ahead and leave this alone for right now, but just note that we're going to be putting more data into this as time goes on. Now, what we're going to do is we're going to come down here and say void hello world : underscore init, and that will be the code that's going to run when Godot starts up. And then we need to add in one last one, void hello world : underscore process, and then float delta. Awesome. So what is all of this? Well, you say void because it's returning nothing. You say hello world because that's the class that this function is under. And then you say : because that's saying, hey, this links to this register methods. Make sense? And same thing over here, void, it's returning nothing. Hello world because it's a class that this function relates to. So that's basically how this all works. It actually relates back to this H file here. So now if we hit Control S, so now that we have all this set up, let's go ahead and print something. So let's go tab Godot : print hello world semicolon. Let's go ahead and save that. Now we're going to need to compile this so that it actually runs. So the first thing that we need to do to get this to compile is create what's called a linking library. And a linking library is how Godot sees this code. So we basically say, hey, Godot, here's where this function is located. Okay. So what we're going to do is we will right click our src file and we will create a new file and we will call it gdlibrary.cpp. And then we need to say #include quote hello world.h, and we need to type xturn quote C, capital C, void gdn underscore, and you're not going to get any IntelliSense here, by the way, export Godot underscore gd native underscore init, Godot underscore gd native init underscore options, asterisk O, and we are going to open and close our parentheses here. And then we're going to say Godot : Godot : gd native underscore init, and we're going to pass in that O. Technically speaking, I don't think this really matters, but we're doing this so that we can pass in a list of these options here into our gd native init. So this is basically us telling Godot, hey, initialize our linking library with our object, okay? And now what we can do is I'm going to go ahead and just copy this and I'm going to paste it. And instead of saying, hey, let's init, we need to do terminate. So terminate, and we need to say, instead of init options, we need to say terminate options. And instead of doing this init here, we need to do terminate. All right, so when Godot initializes, pass in these init options and create our linking library. When we terminate, come in here and run our terminate with these terminate options. So it's basically doing the exact same thing, but the opposite. So now let's go ahead and copy this one more time and paste it. And instead of doing gd native terminate, come up here and change this to Godot Nativescript underscore init. And instead of having this whole mess here, just say void asterisk handle. Now, usually when I see this asterisk, it means that it's a memory pointer of some kind. So it's passing in a type void. So I'm not 100% sure what that is, but I know that this is basically how you do it. So I'm sorry that I can't give you a good explanation there. So next we type native script underscore init handle. So we can pass in that handle here. And finally, here comes the fun part. This is where we register our classes. So we say Godot : register underscore class Godot : hello world. Now, if we wanted to register other classes with Godot, we could totally register them without using Godot and without using hello world. We could pass in literally any library from here, any class library that we want to, and we could register it with Godot. Now, some of them may crash Godot, so that might not be a good idea. You might want to wrap that class into helper functions to help you out, but you could, in theory, do it. So now we're going to go ahead and save. And now from here, we're going to need a sconstruct file. Now, I just happen to have downloaded one. It's right here. But I have one in the link in the description below that you guys can go ahead and download and just use for your own modules. So just go ahead and grab that one. And yeah, we'll use that one. I'm going to drag this into my Godot project here. And I'm going to make sure that it is at the top of my project so that it's not underneath SRC, because if it is, then this will not compile properly. So what is an sconstruct file? An sconstruct file is instructions for C++ to build our plugin. So we have to have this or else our plugin will not build. So you're going to want to get used to reading this and understanding kind of how it works and why it works, right? Now, the first thing that we need to do is we need to come up to the top and we need to name our library. So you can see right here on line 15 is where we actually name our library. So you can see the library name is libgdexample, and we're going to call it hello world. And you can see path where the lib is going to be installed, demo bin. So if you go into your CPP example, you'll see we don't have a bin folder. So let's go ahead and create that. So if we right click new folder, type bin and hit enter, and you'll see that demo here does not exist. What it's trying to do is it's saying demo instead of CPP example. So let's do CPP example. And let's make sure that we have our bin folder here. Now, you don't necessarily have to do it this way. You could do CPP example / library, and that would work as well. But in my case, I'm just going to go with bin because it just makes sense to do it that way. Now, some other things that you can look at. Godot CPP is right here, and you can see that Godot headers, it's right here, so that's good. Godot CPP exists, and CPP lib is libgodot-cpp, which, if I remember correctly, is good. So I think we should be good at this point, and if not, it'll fail on us and we'll go from there. So let's go ahead and save, and let me just open up a terminal inside of Visual Studio here, and let's do scons platform is equal to Windows. It might get mad at me because I didn't do a capital W. Oh, we got some errors here. Oh, we've got some fatals here. Let's see. We have it's already defined in GD library obj hello world void. Oh, it's probably mad because of that constructor. Let's see. Yeah, let's go ahead and pull these constructors out. Control X, and let's put them in our CPP folder instead. So let's just put them at the top and paste them. Let's Control S and Control S. And then let's go ahead and try to recompile and let's see what happens. Oh, it looks like it might work. There we go. It has compiled our targets. Awesome. So you can see we have a DLL file here, and that is our C++ library built. Awesome. That's our first major win in this entire process. So next, we need to create a gdn lib file. What it is it's kind of like a path declaration of where all of your libraries are for the different platforms. So what we're going to do is we're going to right click on our bin. We're going to say new file, and we're going to say hello world.gdnlib. And what that is going to do, and I'm going to throw that in my bin folder. There we go. I mean, you don't have to, but I like to have it there. And what we're going to do is we're going to say bracket general, and then we're going to say singleton, and we're going to make that false. What that means is it a singleton? Are we only allowed one instance of this library loaded into memory one time? So you can only have one in the entire project. Load underscore once is equal to true. We don't want to be reloading this library if we don't have to, so just might as well. Symbol underscore prefix. And this is just the prefix that you want to use when you want to access the various functions that are used for your entry points. So like, for instance, you if you want to access this outside of the Godot editor, you could actually access it with whatever this is called. So in this case, I'm going to go with Godot underscore, and then whatever my function name would be here. Reloadable is equal to false. I don't need to reload it. I don't need to hot reload it. I don't think it's really worth it. We're going to go bracket entry. And in this case, since we don't have any other platforms, we're just going to do Windows. .64, because I have a 64-bit binary here. And we're going to say quote res colon slash bin slash win 64 slash hello world .dll. So it's just pointing to this hello world.dll. So you just make sure you go from your res folder, which would be this one, and bin win64 hello world. And then from here, we can call out our dependencies, which in our case, we don't have any. So Windows .64 is equal to empty. All right. So that's all we need for that. But we need one last file, and you don't have to make this file, but it's a good idea just so that way you have a file that you can reuse. It's basically your script file, so it'd be like your .gd file, right? It's basically your script file. So what I'm going to do is I'm going to right click on my bin folder, and I'm going to create a file, and I'm going to call it hello world .gdns. All right. And we're going to say gd underscore resource type is equal to Nativescript. Load underscore steps is equal to 2. Format is equal to 2 as well. And then we're going to say ext underscore resource path is equal to res colon slash bin slash where our gdnlib file. So that's where this is. It's your external resource. Now in my case, it's in bin because I like it in there. Hello world dot gdnlib. And we're going to say space type is equal to gd native library. ID is equal to 1. And we're going to say resource underscore name is equal to hello world. We're going to say class underscore name is equal to our class name, hello world. And I believe that's what we called it. Yep, hello world. And then I am going to say library is equal to ext resource 1. Oh, whoop, I don't need capital ext. What am I doing? There we go. So now if we open this project up in Godot, which if I open up Godot and I go and I find my CPP example project, I'm going to keep this small. I know that normally I make this the right size. Oh, it's mad at me. Let's see. Hello world, fixed dependencies. What's it mad at me about? Res bin hello world. Oh, did I make a mistake? Bin hello world. There we go. Awesome. So now we'll go ahead and open it anyway. And we're going to go ahead and create a 2D scene. We're going to go up here and drag that gdnlib onto the project. Oh, I think we might have made a mistake somewhere. This is just our pathing to our DLL, so that's fine, and I think that's correct. Let me make sure. It seems to be correct, but our resource is not coming up, which means I probably broke something. Let me see. I probably misspelled something. So GD resource, Nativescript, load step is 2, format is 2, ext resource path res bin hello world dot gdnlib. Type is GD native library, ID is 1, resource name is hello world, class name is hello world, ext resource. Yeah, that should load. Oh, you know what I think? Yep, I think it's because I have a space in here somehow. Let's go back. And there it is, right there. So if we go ahead and throw this on here and we hit play, let's see what happens. Okay, so you can see it says hello world. Awesome. It actually worked. We have our little hello world script calling out and doing a hello world. Okay, so now that we have our hello world working, let's go ahead and set up basically a basic move an object around the screen kind of thing. So we're going to do some get nodes and things like that, so I can show you the flexibility that C# or C++ gives you. So let's first head over to our header file and let's go ahead and add in a few include statements here. So let's go hashtag include, and I'm going to go ahead and include my input class. So input.hpp, and I'm also going to go ahead and include a sprite class because I'm going to want to move a sprite around the screen. And then I'm going to finally include what's called a global constraint, and that's kind of how you get input from the user. So you could do things like, let me get like a key, or let me get a action or something like that. You may not need this, but it helped me out when I did it, so you don't necessarily need it, but we'll go from there. So now I'm going to go ahead and add a float. So float, and I'm going to say time, and I'm going to make that equal to 0. And the reason why you want to make this equal to 0 is because in C++, if you just create a float time, it's going to be initialized with its minimum value, which is like -7 million or some crazy number. So you want to make sure that you just set it to 0, and then it just solves that problem. Next, I'm going to need a vector too, and I'm going to say current position. And then I'm going to also do a sprite. And because this is an object, right, it's a class, I'm going to make a reference to it. So that's what this little asterisk here is for, is to create a reference to that class. So it's kind of like pointing to a section in memory where that class resides. So just something to keep in mind, that you can't just say, I'm going to create a sprite and then build it, because a sprite is different than a sprite reference. So you need to make sure that you do a reference over the actual sprite object. Now, when you want to assign to this object here, or to this, to this reference, you can grab the actual regular sprite object It just, when you declare it, you need to do the asterisks. So then we're going to say current sprite. And finally, down here in my public section, I'm going to create a function. So void move, and I am going to ask it, or I'm going to allow it to have a vector 2, and it's just say position. All right. So that's going to be all the changes that we need to do to our header file. So let's go over to our CPP and let's take a look at that. So the first thing that we need to do is in our init, let's go ahead and do current position. Node asterisk test node is going to be equal to get underscore node, and it's going to be test node. In this case, I'm just going to call it test node because it'll just be simpler. So when we get into Godot, we'll go ahead and create a sprite that's called test node. Actually, we can just call this whatever, really. So we could just call this move sprite object, let's say, and then that will work as well. It really doesn't matter what we call it. Now, let's go ahead and say if our test node does not equal null, one of the things that does not exist inside of the C++ side of Godot is error checking. You are responsible to check if it's null. If you don't, the system will crash. So you need to make sure that you check for that kind of stuff. So then what we'll say is current sprite is equal to cast to sprite, open parentheses, test node, and we'll say current position is equal to current sprite dot get underscore global position. And you'll see that it already creates this little arrow here. And one of the things that I don't think I explained quite yet is what an arrow is. So much like this little asterisks here, which is kind of pointing to a point in memory, same thing with this. This is called a memory pointer. It's saying I am pointing to this object in memory, this function out in memory. And the reason why this is more efficient than doing a dot is because when you do a dot, you are referencing the object that you created. But in this case, this is referencing to the section in memory where this resides. So it's way more efficient and faster than going and getting the reference, because it would have to go get the reference and then go find the object or the function in question. Here, it's literally pointing to the memory address and saying, this is where this is located. So it's way more efficient. So now from here, let's go to our process section and let's say time plus equals delta. And what that's going to do is that's going to give us a good time loop here. So we'll have time incrementing as delta runs through. And then we'll say int move direction is equal to 0. And then we will say input and asterisks, because again, we're doing that memory point. Input is equal to input : get singleton. Okay, and we are actually grabbing, what this is doing is it's going out to Godot and saying, hey, I want the input singleton. So Godot holds all of your input events in a singleton. So when you press a key, it holds that as one giant object instead of holding it as multiple objects. This makes it simpler for us to interact with it, and it's more efficient. So next we're going to say if input dot is action pressed, quote UI underscore right, and then we're going to say move direction is equal to 1. And then we'll say if input dot is action pressed, again, UI underscore left, then I want move direction to be equal to -1. Okay? And now from here, we can go ahead and create our vector2. So vector2 move vector is equal to vector2 times 10. Okay, so that's going to move it times 10, comma, 0 plus current position dot y. So what would this do if we just left this? Okay. Well, if we actually had a move code, what would happen is the object would move to the right times 10. We don't want that, right? We want it to move based off of your direction, right? So we need to wrap this in parentheses and we need to multiply it by our move direction, right? But we also don't want it to snap back to our original position. So we need to wrap all of this in another parenthesis bracket and then multiply it, or I'm sorry, add it to current position dot x. And what that's going to do is that's going to say, hey, my current position needs to be added to whatever this value is. Okay? Now, there are other ways and there are simpler ways of moving an object. I'm just doing this, I guess, more complicated method, I guess you could say, because you could use move and slide, and in theory that would do this simpler, but I wanted to show you guys how to do it manually. So next, I want to go ahead and show you guys that we can actually create our own functions. So I'm going to go down here and go void hello world : move. Okay. Vector2 position. Okay. Now, you don't have to do this. You could just put all of this underneath here, right? But I'm going to abstract that into another function so that way it's just a little bit nicer to work with, right? So what I'm going to do is I am going to say current sprite dot set global position to our position. Okay? And then I'm going to say current position is equal to current sprite dot get global position. I mean, we could actually, to be honest with you, we could make this a little bit more efficient by just saying position. Because we're already setting our global position up here, it would just save us a little bit of stuff. Then we don't have to call out to this function, which is slightly faster. So now, from here, we could expose this to being accessed outside of our project, right? But first, let's go ahead and put this up here. So move and then move vector. Awesome. So from here, the cool thing about abstracting this into its own function is if I come up here, I could register it here, register method, and I can name it whatever I want. So I could name it move, right? And then I could say, all right, and hello world, : right, move. Okay, and what that would do is that would open up the possibilities, whoops, I misspelled world. That would open up the possibilities of us accessing this through GDScript. Now, I'm going to do this in a future video because this video is going to be long already, but it's a really cool way of exposing stuff to GDScript. So you could do a lot of heavy processing in C++ versus doing it inside of GDScript. So now I'm going to save and I'm going to go ahead and recompile. And I will be right back. Okay, we have some compiler errors here. So we have syntax error, missing a semicolon before constraint. So let's go ahead and take a look. Most likely somewhere I just missed a semicolon and it's probably just mad at me for that. Let's see. It says it's in my H file. So let's take a look. Ah, here it is. So let's go ahead and put that in and also get rid of that little symbol there. Sweet. So that is compiled correctly. Awesome. Now, something to note, I did run into an error a little bit ago where it says that I could not do a build because I did not have permissions. Where did I run into that? Let's see. There was a section in here where it says that you have invalid permissions to a file, and I can't find it. But basically, if that happens, go ahead and just close Godot, and then you'll be good to go. So I'm going to go ahead and reopen Godot, and I'm going to go to CPP example, and it's going to reopen. Unfortunately, that's just how it is. There we go. And now we're going to right click on my node, add a child node, and I'm going to add in a sprite. And it has to be a sprite or else this will not work because we directly declared that it is a sprite right here. So it has to be a sprite. So now I'm going to go ahead and drag in my icon here as a texture so it just exists, and I'll just put it somewhere over here. And then I'm going to rename my sprite whatever I named it here, which is move sprite object. So let's go ahead and name this move sprite object so that I make sure that it makes that link. Let's go ahead and hit play and let's see what it does. Oh, we have a crash. So that's a good sign. Let's take a look at our crash. Cannot get path of node as it is not in a scene tree. Node not found. Move sprite object. Let's see. Move sprite object relative to this. Okay, so I figured out what was wrong. So this needs to be moved down here. And the reason why is because it looks like all of this is being ran before the object exists. So it gets ran and then the system goes, I can't find this because the sprite doesn't quite exist yet. So I'm just going to move it down here because for the example, at least we can have an example here. So I'm going to go ahead and compile this. Back inside of Godot, we're going to go ahead and attempt to run this. And let's see what it does. All right, and so you can see if I hit left and right, it moves back left and right, which is awesome. That's exactly what we wanted. So that is all I have for you guys today. So we went through the process of setting up our C++ project. We went through the process of setting up all of our small little details that we need to, like our linking libraries and our Godot libraries and our assets and our resources. We ran through the process of setting up a small left and right controller here that's not perfect, but it works. And we talked about what a header file is and why it's useful. And last but not least, we debugged a lot of problems. But that is all I have for you guys today. So if you like this video, go ahead and hit that like button. Hey, if you dislike this video, go ahead and hit that dislike button because I'm here to make content for you guys. If you have any questions, go ahead and throw them in the comments below or hit me up on Discord and I'd be more than happy to help you out. And if you guys have any suggestions for future tutorials, please leave them in the comments below. This video was a viewer suggestion, so I take your guys' suggestions extremely seriously. So let me know if you guys have any cool ideas or anything you'd like me to cover, and I'd be more than happy to get to them. But that is all I have for you guys today, so thank you so much again for watching, and I will see you all next time. Thanks.